Differentiation. We want to differentiate some functions here today using quotient function derivative. That is, whenever we have a quotient function, it is very easy for us to differentiate the function by using quotient function derivative method. Now, if we have a function like y equals to u of x over v of x, this is a quotient function already, because this is numerator and this is denominator. It's a fraction. So this is a function on its own, another function. So that means it's a quotient function. To differentiate that, we use the formula. The numerator is u and the denominator is v. So dy dx in this case will be v du dx minus u dv dx all over v squared. So this is the formula that we'll continue to use in solving, in differentiating quotient functions. Examples. Let's look at one or two examples today. Taking example 1. To obtain dy dx, if we have a function y equals to x raised to power 5, x raised to power 5 all over x raised to power 3. It is obvious from here that our u is x raised to power 5 and our v is x raised to power 3. We normally make the numerator u and denominator v. So differentiating them one by one, du dx will be 5x to power 4, while dv dx will be 3x to power 2. Now, so we have our u, we have our v, we have our du dx, and we have our dv dx. So we can input all this into the formula. This formula here that is called quotient function derivative formula can now be applied. Now we have dy dx as v du dx, that is x cubed times our du dx is 5x to the power 4, then minus u. What's our u? Our u is x to the power 5 times dv dx. Our dv dx is 3x squared. Then everything all over v squared. Our v is s cubed, so s cubed squared, that's v squared. Now we have s cubed times 5x to the power 4, that's a 5x to the power 7, minus x to the power 5 times 3x squared, that's 3x to the power 7, all over s cubed squared is x to the power 6. So we have 5x to the power 7 minus 3x to the power 7, that is 2x to the power 7, all over x to the power 6. So we now have, this will cancel 6 out of here, so we now have 2x. So dy dx of this function, this quotient function, is actually 2x. So the derivative is 2x. That's the differentiation for that. Alternatively, we can just break everything down using law of indices. We know that our y will now be equal to x to the power 5 minus 3 now, and that will be x to the power 2. So we can differentiate the function using power function rule. Then we're going to have 2x to the power 2 minus 1, which is 2x to the power 1, which is 2x. So that's an alternative method. So we still get the same thing, though faster. Then another question. Let's take another example. Example 2. We have y to be equal to 2x minus 1 all over x squared. Again, we know that our u is 2x minus 1 and v is equal to x squared. So the u dx here will be 2, while the v dx will be 2x. Now, using the formula for quotient function, we have dy dx to be equal to v du dx. Our v is x squared, then times du dx, which is 2, then minus u the v dx. Our u is 2x minus 1. It's a compound expression, so we introduce a bracket, then times dv dx. Our dv dx is 2x. Everything over v squared, that's s squared squared. So we have 2x squared. Now 2x times 2x, that's 4x squared, then times minus, that's minus 4x squared, then minus 1 times 2x, that's minus 2x, times minus, that's plus 2x, all over x raised to power 4. Now that is what we have. Now we can finalize by find the difference between this. We have 2x squared minus 4x squared, that's minus 2x squared. We have minus 2x squared there, then plus 2x all over x to the power 4. Now x is common, we can bring x out there, so we have minus 2x into x minus 1 all over x to the power 4. So our final answer is cancelled here, so we have minus 2 into x minus 1 all over x cubed. So that is the differential function of this quotient function. So we have minus 2 into x minus 1 over x cubed. So that's our final answer. The last example that we're going to take on this particular topic, this quotient function rule, is y equal to 1 plus x all over 1 minus x. It's obvious that our u is 1 plus x and v is 1 minus x. So du dx automatically will be 1, while dv dx will be derivative of this function, which is minus 1. So dy dx using the quotient function rule is v du dx, v is 1 minus x, then du dx is 1, then minus u, which is 1 plus x, dv dx, which is times minus 1, all over v squared, which is 1 minus x all squared. So we have, this is 1 minus x, 1 times minus 1, that's minus 1, times minus, that's plus 1, x times minus 1, that's minus x, times minus, that's plus x, all over 1 minus x all squared. So we have 1 plus 1, that's 2, minus x plus x, that's 0, so we have 2 over 1 minus x all squared. So that is the derivative of that of function y equals to 1 plus x all over 1 minus x using quotient function derivative method. Thank you very much. I wish you all the best.